All right, so now we're getting into bases other than the natural log. We did a lot of natural log stuff, the natural number, E. Now we're going to be going to generally any real number, but most of them are, the bases are whole numbers, positive whole numbers. But it technically can involve any real number. Now, I'm going to kind of give you a heads up here. I don't know what your college professor is going to do when you take calc in college, and I assume that's why you're here, because you will be taking calculus in college. When I was in high school and college, there was a number of these processes that we had to memorize. I don't remember memorizing this, but then that was back in the Stone Ages. You don't have to worry about memorizing them. My job at the high school level, in my opinion, is that I get you to improve your manipulative skills and deal with a different view of mathematics from what you've had up to this point. A lot of classes in college or majors in college will ask you to have calculus, including business, particularly if you're in economics. There's some economics classes that use calculus, so if you're getting involved in that, I'm not sure what type of stuff you're doing. Most likely it's going to involve natural log stuff. I'm not so sure about this, but regardless, your job is to be able to take situations like this, where I have theorem 513, which are the derivatives for bases other than E. There's 4 of them that we give you here. So when you do the practice problems, you follow one of these 4 patterns. The derivative of a to the x is the natural log of a times a to the x power, where x is any number. The derivative of a to the u power, this is the chain rule thing, natural log of a times a to the u du dx. And the derivative with respect to x of the log of base a of x is 1 over the natural log of a times x. Okay, and then the derivative of the log base a of u, same thing, natural log of a u du dx. Now, why do they not have dx's here? It's because this would technically be dx dx, and dx over dx is 1, so they don't include it. But technically, these pairs are the same and these pairs are the same. The difference is that you're substituting in something to make the problem easier to solve. Then you're resubstituting back in whatever your value of u was. Theorem 514, power rule for real exponents. Nothing new here. This is the same basic idea as what we dealt with in the chapter 2. The only difference here is now that it's now being in the context of what we're dealing with now, but exactly the same. You bring n in front, and then you subtract 1 from the exponent here. Same with the u, same thing, du dx. So your job for this assignment is to be able to find which of these 6 fit your problem that you're dealing with. So let's take a look at that. Number 37, we have 4 to the x power is the problem, and according to 513, when you derive that, it's going to be the natural log of the base 4 times 4 to the x power. For number 39, this is a product rule problem. You're going to take t squared times the derivative of that, which is natural log of 2 times 2 to the t power, plus, and then 2 to the t power times the derivative of that. We take the 2 in front and subtract 1 from the 2, and you get 2 to the t power here times, and then t squared natural log of 2. And then the second term of this expression is going to be 2 to the t power times 2 times t. And we can factor out a 2 to the t power out of each term, and we can factor out a t out of each term. And that's going to, when that happens, then we take 2 to the t times t out of here, leaves you a t here times the natural log of 2. Take a 2 to the t and a t out of here, and that leaves you 2. And there's your answer.